Bismillahirrahmanirrahim. Assalamu alaikum. In this lecture, we will discuss how to create defects in materials, especially in material sense. People are interested to create defects, to create if I say in a very concise form that people are interested to create materials for practical applications. They want to create defects in materials. They want to create heterojunctions, structures, other strategy they use for getting of the material. So that is why if you are interested to create doping in materials, in this lecture we will discuss how to create doping through materials to you. For that you should have your structure. You can build your pure material from here. You can import your structure, your material from the library of materials to you. For example, we are interested in semiconductor material, like these are all semiconductor compounds. If you are interested in pure silicon, this is the pure silicon unit cell. So here you can change the style of the structure. You can label silicon by unit of your interested direction. Symbol is okay. If you are interested to build the supercell of this material, we can create from here supercell. If we want to the part of the circuit, so from there you can get the structure. Now they are interested to create monodop, tridop, or tridop. From here, so for that you first select element of silicon. When you select the element of silicon, so there, and there you can open. If you want to drop down, you can drop down. So we create monodop for crystal of silicon. If you want to create monodop, you can the same way. Sporus, you want to get the sporus, create the sporus, and if you want to create tridop, so the same way you can add materials. So here when we create tridop, there is only this method, but there also the silicon pattern is replaced by glue. It's because of that when you create impurity in material, so you have to the symmetry will prepare a pharmaceutical process. So through this you can create impurities in materials. You can create monodoping, Tridoping, create impurities in your stress. With this, you will get silicon according to your applications. After that, you will like calculation step for optimizations. First of all, you will optimize the structure with the corrective medium, the ETA PVA function in the method. So we can check here you need to change the medium quality. All the thing will be there according to the medium. So through this we can get my structure with the average result. If you want to see your result, you will change the quality accordingly. That will be what to drop the code, write all the code of the PC, and run your application. You can see in the description phase what calculation is doing. So you can get your desired result.